Hello, everyone. Welcome to the session Speak Up Kalpana. I am Shivani, and the goal of our session is to introduce you to the people, accomplished people in STEM fields with whom you can interact to know more about their work and their journey. And we hope this helps you in deciding your own career path. So let's start with the theme of this month, Women in Science and Engineering. And today on National Science Day, we have Dr. Nimisha Kumari joining us, who is an astronomer at the Space Telescope Science Institute in USA. Her research interests are understanding stars and galaxy formation and its evolution. And today we will hear about her story, how she became an astronomer, and her work as a part of the team which is launching the largest telescope in the space ever. And she also believes in making education and astronomy available to children and students. And she has also been a part of several outreach programs. And I also had the pleasure to meet her in one of the Vigyan Shala's outreach program. So let's welcome Dr. Nimisha Kumari. Nimisha, it's so good to have you here. Thank you so much for joining us today. And we are super excited to hear your talk on demystifying the universe with James Webb Space Telescope. So over to you.
Thank you so much, Shivani. Hi, everyone. And thanks to Shivani, Vijay, for inviting me to give a talk on the occasion of National Science Day in India, and also Darshana Joshi, the lead of Vigyan Shala International, for this great initiative. So I'm Nimisha Kumari, as you already know. I'm an ESA Aura astronomer at the Space Telescope Science Institute, where I'm a member of Science and Operations team of James Webb Space Telescope. As such, I'm involved in various activities related to the commissioning of this telescope. So here is an image of JWST, or James Webb Space Telescope, where all of its components are fully deployed. Apart from supporting this telescope, I also spend time in understanding the cosmos via research. My research is mainly driven by questions related to galaxy formation and evolution, and more specifically, the chemical evolution of the universe. Some of these questions will be addressed by the observations taken by the JWST. So today I'm going to talk about how this much awaited telescope is going to revolutionize the field of astronomy and push the frontiers of human understanding of the universe. However, I was asked by the organizers to talk about my journey from childhood to now. So before talking about JWST, I will spend a few minutes about my professional journey. I was born and brought up in Bihar and Jharkhand, the two states in India. My father had a transferable job, so I had my education in different schools. However, the majority of my school was at DAV Public School in Khuti, which is a tribal district in Jharkhand. After completing my school education, I was fortunate to get admitted to the Miranda House in the University of Delhi, where I completed a Bachelor's of Science honors in physics. Apart from the formal education, Miranda House provided me with several opportunities to participate in extracurricular activities, which helped me expand my horizons. At the end of the third year in the Miranda House, I secured a scholarship to go to France for a master's degree. I completed master's degrees in physics and astronomy at one of the most prestigious engineering schools of France, that is École Polytechnique. Then I secured a couple of scholarships at the University of Cambridge to do a PhD in astronomy. That was a very important step in my career to become an astronomer. After finishing my PhD, I stayed in Cambridge for about a year to do a postdoc as a Schlumberger Fellow. And then later, I did another postdoc as an STSCI Prize Fellow at the Space Telescope Science Institute in the US. During that time, I also supported one of the instruments of the Hubble Space Telescope. After a year, I was hired by the European Space Agency as an ESA Aura astronomer to work on the joint missions of ESA and NASA. My first mission as an ESA Aura astronomer is James Webb Space Telescope, and supporting JWST is a dream come true because I wanted to work on this telescope even before I started my PhD. So that is for almost 7 years. I'm very excited to work with the science and operations team of JWST at the Space Telescope Science Institute, or STSCI. STSCI is the Mission Operations Center for the Hubble Space Telescope and James Webb Space Telescope. It is within the campus of Johns Hopkins University and is operated for NASA by the AURA. AURA is spelled as Association of Universities for Research in Astronomy in the US. It employs almost 800 people involved in various activities related to these two telescopes. On the left here is the picture of Hubble Space Telescope, also called HST or just Hubble. And this telescope is in operation for over 30 years now. As I already mentioned, I was very fortunate to support this amazing telescope, which is one of the most versatile space telescopes and has led to many discoveries. One successor of Hubble is the James Webb Space Telescope, whose idea was conceived in 1996. However, it is much more powerful than Hubble. JWST is the largest telescope ever launched into space. While the primary mirror of Hubble is about 2.4 meters, in comparison, you can see that JWST's mirror is much larger. Its primary mirror is about 6.4 meters. So as shown in this figure here, it is made up of 18 hexagonal segments. The reason for having segmented mirror is that the segments can be folded and be fit into the rocket to send into space. A single mirror of this size is impractical to send into space. Also, the mirror of JWST is usually shown in yellow in figures. This is because the segments are gold-plated beryllium. Anyway, moving on to another interesting component of this telescope, and that is the Sunshield of JWST, which is shown in this figure here. There are 5 layers of this Sunshield, which are as thin as that of human hair, and they are as large as that of tennis court. You can also get an idea of its size by the number of people standing beside the Sunshield in this figure. Now, you might be wondering, what is the purpose of this Sunshield? And Sunshield, as its name implies, is shielding us from the light and heat from the sun, and actually also the earth and moon. It is just like an umbrella near the beach. So, and why is it needed? Because JWST is an infrared telescope, so it needs to be kept cool under 50 Kelvin. That is about minus 223.2 degrees Celsius. So that is pretty cool. And if we don't have the Sunshield, then the infrared radiation from the telescope itself will overwhelm all of the observations. So the Sunshield is used to block light and heat from the sun, earth, and the moon. Now let's look into the instruments in JWST, which will be used to make these observations. So here on the left is a figure of JWST, and behind the primary mirror of JWST, there is a component which is highlighted in color, and that is eSIM. eSIM stands for Integrated Science Instrument Modules, which serve several purposes, but here I particularly mention it because it holds 4 science instruments and a guide camera. These 4 instruments are MIRI, FGS, NIRCam, and NIRSPEC. So MIRI stands for Mid-Infrared Instrument. It is provided by ESA and NASA JPL. Then NIRSPEC is Near Infrared Spectrometer or spectrograph that is provided by ESA and NASA GSFC. After that, there is NIRCam, Near Infrared Camera from University of Arizona, and then FGS NIRIS, That is from Canadian Space Agency. Now, some of you might already be wondering when and how will this giant telescope be launched into space? So JWST is scheduled to be launched in October this year. It will be launched on an Ariane 5 rocket from the European spaceport Kourou in French Guiana. And that you can see on this tiny map of the world or the globe. Before launching, the mirrors as well as the Sunshield of the telescope will be folded to fit into the rocket, as we can see in these two figures on the right. I hope you can admire how the mirror of JWST is folded into the fairing of the rocket. So after the launch, the telescope will deploy during its 30-day journey to the planned orbit, which is about 1.5 million kilometers from the Earth. And that is a pretty large distance. For comparison, for example, Hubble is just 550 kilometers from the Earth. And the orbit is planned to be at L2 for several reasons. One of the reason is to keep it on the same side of the Sun-Earth-Moon system. As such, a single sun shield is sufficient to block the light and heat from the Sun-Earth-Moon system and keep the telescope cool. The details of the deployment can be found in this YouTube link at the bottom of this slide. And if we have time later, we can probably watch this YouTube video together. Even if we don't, then I highly encourage you guys to watch this video, because this video is showing each step of deployment, which is quite impressive. And specifically, the unfolding of the mirrors and Sunshield is amazing. So though it will take only 30 days for the JWST to reach L2 point, the planned orbit, it will take another 5 months to commission all of its instruments. The instruments which I was talking about, NIRI, NIRSPEC, NIRCam, and FGS NIRIS. So it will be only after 6 months of launch that JWST will start science operations. So what are the science goals of JWST? There are in fact 4, which I show on this slide. I will go over each of them in detail in the coming slides, but here is just a summary first. The first one is to observe the first stars and first galaxies, or simply first light. The upper left image here shows a snapshot from a simulation of the formation of first galaxies in our universe. Now, the next science goal is to understand the assembly of galaxies, which address various topics, and one of them is galaxy interaction. So the upper right image here shows 2 interacting galaxies looking like a flower rose. This is quite impressive, actually, that we get to see so many beautiful figures when we do astronomy. And the next goal of JWST is to understand the formation of stars and planetary systems. The figure on the lower left shows a stellar nursery where stars are forming. And finally, the last but not the least is to understand the origin of life by understanding the planetary systems. The lower right figure here shows Mars, one of the planets in our solar system. So the first science goal of JWST is to study the first light. To understand this goal, let us have a look at the cartoon picture here, illustrating the evolution of the universe. After the Big Bang around 13.8 billion years ago, the universe was like a hot soup. After about 370,000 years of the Big Bang, the protons and electrons combined to form neutral hydrogen. That period is called the epoch of recombination, And that was followed by dark ages, cosmic dark ages, as it is called, when there were no stars or galaxies. The first stars formed around a few 100 million years after the Big Bang. These first stars and galaxies then reionized the universe, which is called the epoch of reionization. After this reionization era, modern galaxies were formed, and currently we are living in the present-day universe. With James Webb Space Telescope, we will be looking back in time continuously up to 13.4 billion years into the past. And I find it really amazing. These observations are planned to focus on finding the first galaxies and then understanding their properties. Some of the important questions which JWST will address are: how was the universe reionized? What were the sources which reionized the universe? What are the properties of those first galaxies? Now, to the next science goal of JWST, galaxy assembly. We might already know that a galaxy is a system of millions or billions of stars together with gas and dust, held together by gravitational attraction. This is an image of a small region of space taken by Hubble Space Telescope over a period of 6 months. So this region is smaller than 1 millimeter by 1 millimeter square piece of paper held at a distance of 1 meter away. I would like to imagine how tiny it is. Just 1 millimeter by 1 millimeter at a distance of 1 meter away. That is equal to roughly 1/13 millionth of the total area of the sky. And it contains around 10,000 galaxies. And that is quite amazing. So here is now a zoomed image of a portion of that image shown earlier on the slide, which shows that our universe hosts a variety of galaxies which come in different shapes and sizes and vary in their physical and chemical properties. For example, there are elliptical galaxies which do not form stars anymore. Then there are spiral galaxies of different types. Some of them have very well-defined bars. Some of them don't have any bars at all, while some of them have bars, but they are not very well-defined. And there are some other galaxies which do not have any particular shape, and they are called irregular galaxies. So for giving context, I have worked both on spiral galaxies and irregular galaxies. So JWST will help address questions such as: how do galaxies form and evolve? What leads to different shapes of galaxies? How are different chemical elements distributed within galaxies? And what happens when different galaxies collide? You might remember I showed you a picture of interacting galaxies earlier. That was the collision of galaxies. Now the next science goal, star and planet formation. On this slide here, we see images of a star-forming region, Eagle Nebula, taken by the Hubble Space Telescope. On the left is an image taken in the visible or optical light, while on the right is the image of the same region taken in the infrared. So generally, a star-forming region is enshrouded in dust, which absorb or scatter the optical light and emit at longer wavelengths, such as infrared. So an infrared observation can show dust-obscured regions of star formation and hence reveal a lot of information. For example, here on the right-hand image, which is the infrared image taken by Hubble, we already see a lot of details which were not visible in the optical image on the left. Now just imagine JWST is about 100 times more powerful than Hubble. And as such, it will allow us to make very detailed and in-depth analysis. By the way, before moving on to the next thing, I will like to give you small information about this image showing Eagle Nebula. The elongated structure here in these images are called the pillars of creation. So the star formation has been studied in great detail. However, there are a lot of things which we don't understand about star formation. For example, we know that stars form in clouds of gas and dust, which collapse to form stars. However, we don't understand how this process occurs. We have observed that the stars form in groups, but we don't know the reason for this. We also know that metals form in stars and then are recycled into the next generation of stars, but we don't understand the intermediate processes very well. Similarly, we don't understand very well how planetary systems form. So JWST will allow us to perform very detailed studies and address these questions. And now the final goal of JWST, that is to understand the origin of life in the context of planetary system. You might already know that our solar system consists of some planets, asteroids, comets, and Kuiper belt objects. This figure here shows that the red planet Mars, and which is being orbited by its moon Phobos. This image was also taken by Hubble Space Telescope, and you might already know that there are several rovers which have been sent onto Mars. And one of the main goals of these missions is to find the signatures of life, not only within our solar system, but also in other planetary systems, that is, in the planets outside of our solar system called exoplanets. So the infrared capabilities of JWST will allow us to study the atmosphere of planets to address several pressing questions, such as how do planets form and evolve, what are the physical and chemical properties of matter which came together to form planets, how life came into existence on the Earth, was there life on other planets, can we find habitable exoplanets. So with this, I will end my talk, and I hope that I have convinced you that JWST will revolutionize our understanding of the universe. With this, I would like to thank all of you for your attention, and I'm ready to take any of your questions. Thank you.
Thank you, Nimisha. That was, I must say that this was a stellar presentation. Yeah. And such things always amazes me, that how far we have come in our understanding of the universe, and there's still to explore more. And this is an amazing work. Like, I'm convinced. Yeah. So let's see if we have any question. Oh, I can already see one raised hand. So yeah, Dimple Gupta. So you can unmute yourself and directly ask question.
Yes, ma'am. I wanted to ask that will this be keeping a check on the Perseverance rover that recently landed on Mars?
Well, I'm really happy that you are keeping track of different missions. And yes, Perseverance was recently sent to Mars, and JWST will complement, actually both of the missions will complement each other. So while Perseverance is on Mars and collecting samples, what JWST will do is take the infrared observations of the atmosphere of Mars and look for organics, so the biosignatures, for example, molecules like methane carbon dioxide, and that will allow us to look for signatures. And yeah, those two missions are supposed to complement each other. Thanks for the question. That was a very good one.
Thank you, ma'am.
Yeah, that was a great question. So, any more questions? Speak up, audience. Okay, so in the meantime, I'll ask the questions. So yeah, so Namisha, you said that so JWST will be 1.5 million kilometers away from the Earth.
Mm-hmm.
So with that, do you mean that it will revolve around the sun?
Yes. So it is at the point L2. I will show you that image here.
Yeah.
So you see there is you can see my arrow, right?
Yeah.
Here is the sun, here is the Earth, and then the moon, and L2 will be here. So it is revolving with the Earth.
Okay. So it's like an artificial planet.
Well, so, we would like to think that it is revolving around the sun, so people might think that it is a planet, but there are different characteristics of a planet. The first thing is a planet should be an astronomical object, and this is not an astronomical object. So because of that, we can't say that it is a planet. However, another thing to keep in mind is that there are several other tiny objects in the solar system, for example, comets, asteroids, Kuiper belt objects, which are also going around the sun, and they have different properties, and they can't be called planets either, because there are different properties which characterize an object to be called a planet. So yeah, I hope I answered your question.
Yeah, got it. Yeah, thanks. Okay, so yeah, Sharmila.
Nimisha, that was a great talk. Thank you very much.
Thanks, Sharmila.
And I had a question about the coating in the mirror. So you mentioned it's gold-plated beryllium. I believe usually what I've heard about telescopes and even household mirrors is you have either silver or aluminium. Is there a reason for the use of gold-plated beryllium?
Yes, you're right. Actually, the reason is that JWST is going to observe in infrared, and the gold-plated beryllium will reflect infrared light very well, and that is the reason why gold-plated beryllium is used for the mirror.
I see. Okay, thank you.
Okay, so there is one more question from Vijay, that what is the distance between the telescope and the sun?
Okay, so here between the sun and the Earth, it is 150 million kilometers, and from the Earth and the telescope, it is 1.5 million kilometers. So 1.5 million kilometers in front of 150 million kilometer is quite small. So I would say around 150 million kilometers.
Okay. Okay, yeah. Any more questions?
If we don't have a lot of questions, then I would be happy to show a video. Just let me know.
Oh yeah, sure. But I think there is there's a question from Dimple. Yes, Dimple, go ahead.
Ma'am, I wanted to ask that this JWST, it is only taking the energy to reach at the only orbit set होने के लिए इसे energy चाहिए होगी, then it will revolve and उसको कोई energy नहीं चाहिए होगी.
Sorry, Dimple, your voice was not clear. Can you repeat your question again? Dimple, can you please repeat your question?
Yes, ma'am. I wanted to ask that the JWST, it will take energy. it will use energy to reach at L2 point. So and after reaching at L2 point, will it take will it use any energy to revolve around the sun, or it will um, in the gravitational field?
Yeah, you are right. Exactly. That's also a very good question. So GWST has space bus, and that space bus consists of the electrical power subsystem, which provides electricity to GWST spacecraft, and that consists of solar panels and rechargeable batteries. And that is how the energy is being provided for the operations of GWST. So to give you an idea, those solar panels are about 20 foot large. And yeah, did I answer your question?
Yes. Okay. Thank you.
You're welcome.
Okay, there's one more question. Can we have a telescope near Mercury or orbiting Mercury?
Well, telescope near Mercury or orbiting Mercury. Why would you like to have a telescope near Mercury?
I have no idea. There's a question.
I think that you can you can have whatever you want to, and we should let our mind imagine, because imagination leads to inventions. So why not?
Yeah, true. I can see one more hand raised. So Sharmila, do you have any question or?
Yes.
Okay.
Also a general question about about the career. So do you have any advice for students who are interested in exploring astronomy and related studies? Like, what can they do to get more involved?
Yeah. Right. So I will have different advice for students at different at different stages of schooling or college. So, for example, when you are just a school student, I would say that focus on your studies, complete your coursework, which is quite important. However, it does not mean that you don't participate in extracurricular activities. You must participate in extracurricular activities. And when you are in college, for example, when you have already, when the students who are in science fields in college, I would advise that you should look for opportunities. For example, internships in various institutes. If you are in India, there are several opportunities provided in India as well. For example, there was a vacation students program by IUCAM in Pune, which I attended in the last year of my bachelor's degree, and that was a good program as well. So try to get involved in those programs, because they provide you with an overview of what is going on in the field now, and helps you keep informed so that you can make informed career choices. So that will be another advice. And then as you progress in your career, the most important thing is to keep yourself informed. So talk to people, talk to friends, look out for opportunities, and you will get there if you really want to.
Thank you very much. That was great advice.
Yeah, that was a great question. And adding on to that question, so Nimisha, are there any opportunities you wish that you had known them before when you were an undergrad student?
Well, as an undergrad in Miranda House, in the University of Delhi, I would say that I was really very fortunate, because just being in Miranda House and the University of Delhi provided me with a lot of opportunities, and opportunities in the sense that even if there were no opportunities, well, there were, I will expand it on about it on a bit, but even if there were no opportunities right in the university, there were information about them. And that was possible because Miranda House is a great college and the University of Delhi is a great university. So I was, by participating in different activities which were organized throughout the university, I could get informed about various activities or various opportunities. For example, I represented Miranda House along with 3 other students from different departments in Miranda House, from life sciences, chemistry. I was from physics. And we represented the college in a quiz competition that was in university level. And because of our participation at the end, I was sent to IUCA for attending the VSP Vacation Student Program. So the university itself actually provided me with great opportunities. So I would say that try to put yourself in environments and participate in such activities so that the opportunities come to you.
Yeah, very true. Yeah, that be very active. You never know where it can lead you.
Yes.
Yeah.
Exactly.
Okay.
I would also say one more thing, that before undergrad, I was studying in schools in Bihar and Jharkhand, and those are some of the underdeveloped states in India, you might already know. However, from the very beginning in my childhood, I was convinced, and especially that was because of my mother, that education is quite important. And it was only for the higher education that I wanted to, I was persevering for higher and good education. And just that perseverance led me to Miranda House. So, and from there, my horizons were expanded. So, as I answered previously to Sharmila's question, I think that when you are in school, complete your coursework, focus on that, but do get involved in extracurricular activities which will help you. Yeah, I hope I answered your question.
Yeah.
Shivani.
Thanks, Nimisha. Yes, Dimple have a question. So, Dimple.
Ma'am, could you suggest some sites or from where we can get connected to the opportunities? Like you said that you are connected to the opportunities by a university. So how can the non-university students can connect?
So yeah, why not? I think something which we didn't have at the time, so 10 years ago when I did my undergrad, or we had, but we were not very exposed to internet at that time, 10 years ago when I was in India. However, now all of us are very much exposed to internet. Not all of us, but a lot of us are exposed to internet, and that opens bundle of opportunities. So for example, even if you are not in a university, look out for opportunities. And some of the programs I will already mention is, for example, Vacation Students Program in IUCA. Then there is this another program, SASP, which is organized by Baltimore, STSCI Baltimore, where I'm working, and that program is open to all of the students in the world. I mentioned that specifically because not all of the programs in the US are open to non-citizens. So I had attended that program. I mean, there is a competition as well for that one, but you can do an internship there, and that for me, that provided me with a lot of exposure, because that was my first astronomy project, and that led to a paper, and then which helped me further in my PhD and everything. So yeah, VSP program, then SASP, then also, even if there are no programs available, you can, if you are interested, if there is something you really like, then you can actually write to professors working in different universities and say, hey, can I come and work with you for a few weeks or a week, or shadow you for a week, so that you get an idea of the kind of work they do, or their lifestyle, which will allow you to understand whether this is something for you. Because for a lot of people, it is not really clear what they want in their lives. And shadowing professors doing different science research will also give you an idea of what kind of research you want to involve in, or you don't want to involve in, because even though research appears very interesting, it is not for everyone. All of us have different vocations, I would say, and the most important thing is to be happy and satisfied whatever we do. Did I answer your question, Chumpa?
Yes, ma'am, you do.
Great.
Okay, great. Yeah, so Nimisha, one more question from Gunja, that how are you studying a microbe's life on space?
That's a difficult question, because I am not studying that. My expertise is not in microbes. My expertise is in galaxy formation and evolution, and chemical evolution of the universe, and for example, star formation. And yes, actually, with JWST, for example, we will be able to have the infrared spectroscopy of the atmosphere of planets, and that will give us information about the organics. I mean, what kind of environment is suitable for supporting life, or for example, microbes, or if there were microbes, because those are some of the pressing questions. Was there ever life on Mars? Or for example, how Earth, how life originated on Earth. So, well, that is not a question which I can answer as an expert. So I'm sorry for that.
But I think you have given kind of idea what JWST is capable of doing. Yeah. Yeah. So one more question. So it is, how close can you go to the sun for the satellite without burning the satellite?
Yeah, actually, this question is somehow related to if we can have a satellite around Mars, because not Mars, Mercury, because someone had asked a question earlier. Can we have a telescope near Mercury? And Mercury is very close to the sun. So that's a good question, and I don't really have an answer for that question, because so you see, for example, for a GWST, we are using Sunshield to protect the telescope from the heat and light of the sun. So I'm not really sure how close we can get, because it is possible to have some technology which will allow us to overcome some of those challenges. But yeah, I don't have the exact distance to which we can actually go closer to the sun.
Okay, I think we can take one more question. So Sharmila, I can see your hand raised.
Okay. You mentioned that this can see more things than Hubble can. So are the observations from Hubble still going to be relevant after this telescope is fully functional?
Yes, that's a very good question as well. Yes, these observations will remain relevant. Why? Because I never told you during the talk, but one of the strengths of Hubble is that it is an observatory which is designed to observe in ultraviolet, and JWST is designed to observe in infrared. So I don't know if you guys know that ultraviolet and infrared will provide us different information of the same object. I can show you one thing, for example. I lost my cursor, sorry, just a moment. Yes. So here, for example, this is an optical image and this is an infrared image, right? So in the optical image, you see different details, and in infrared image, you see different details. Both of the images are taken by Hubble. Hubble also allows you to take ultraviolet, and in ultraviolet, you will have different information. So for example, with optical and ultraviolet, you know, like one of the information sources which reionize the universe. And what were the first galaxies? What were the properties of first galaxies? And in the local universe, we are trying to, or not trying, we have been trying to do it for a very long time, and the effort is still going, that we are trying to understand the galaxies which resemble the galaxies which were first formed. So on one hand, Hubble Space Telescope will allow us to take ultraviolet observations of the galaxies found nearby in the nearby local universe, and JWST will provide us with the information of the first galaxies which are similar to these local analogs in the ultraviolet as well. And then we can compare the properties of these two sets and expand our understanding, because one thing is for sure, that the local universe, since we have studied it so much, we understand it very well. There are so many details which we understand very well. So the information from Hubble is going to provide us with a framework, or to build upon, and that is all a reason why JWST is called the successor of Hubble. Did I answer your question, Sharmila?
Yeah. Oh, definitely. Yeah. That's very cool, actually. So you're saying they kind of complement each other. It's not.
So Hubble will complement JWST, right?
Yeah. Okay. Thank you.
Actually, one of the interesting things this is a very favorite topic of mine, so I can go on forever. So for example, this image of the sky, and I already mentioned that it is a very tiny fraction of sky, 1/13 millionth of the total area of sky, and there are 10,000 galaxies, and this image was taken by Hubble Space Telescope, and JWST is planned to observe these objects. And what I mean observe these objects is to take the spectra of these objects, and these spectra will give us information about, like, several information, physical and chemical properties. I had briefly mentioned during my talk about the chemical properties, because the spectra of these galaxies tell us the metal content of of the galaxies or the interstellar medium, and JWST will allow us to do that. In fact, just on Friday, I was reviewing a program which is supposed to be observed with nurse spec instrument of JWST, and that was focusing on this area of the sky.
Mm-hmm.
Yeah. That's very interesting. Yeah, thank you.
Yeah, that's really awesome. And so, see, seriously, I mean, very small field of view, 1 mm by 1 mm. I mean, it's just like a point. I mean, we can say like a kind of point, and 10,000 galaxies in that point. I mean,
Exactly.
Yeah. This is really awesome. Yes. Dimple, do you have any question? I mean, I can see your hand raised.
Yes.
Okay. Yeah, so we can take one last question. Yeah.
So I wanted to ask that I am doing BTech in computer science, so that's not very related to astronomy, but I have a huge interest in astronomy. So how can I pursue that?
Actually, the BTech in computer science is actually relevant to have a career in astronomy, because you might not know, but we astronomers spend a lot of time, actually most of my time, on laptop or on machines where we are programming and coding, and because these are because with telescopes such as these, JWST, or for example, there are several other telescopes coming up. Roman Space Telescope, which is scheduled to be launched in 2025 or mid 2020s. Then there is this LSST. So all of these telescopes are going to provide us with a lot of data, and those data need to be analyzed and processed, and for that we need to have computing power, and we need to understand what I'm trying to say is that by doing a BTech in computer science, you are on a right path, or you are on a path to become an astronomer if you really want to be. It's not that if you have a degree in physics or astronomy that you can become an astronomer. In fact, for me, as an undergrad, I had no course at all in astronomy. I only did my course in physics honors had no astronomy lessons at all. We had some mechanics course, but that mechanics is not really astronomy. So there are different paths to become an astronomer. So you can have a degree in mathematics, you can have a degree in physics, chemistry, computer science, and after that you can apply your understanding to various fields in astronomy. For example, I do a lot of spectroscopy, and for doing spectroscopy, the basis of that is chemistry. Or for example, you can have a degree in biology and you can still become an astronomer. There is a subfield, astrobiology. So even when you are doing a course in BTech computer science, I'm sure that you can apply it to several fields in astronomy and become an astronomer if you want to. Did I answer your question?
Yes, ma'am. Also, I wanted to ask that I have been reading some articles on the internet about astronomy. So, can you suggest me some books on basic level that I can read?
On astronomy? Sorry, I missed your question. Did you? Hello?
Dimple, so
Yes,
what kind of books you're asking for? I mean, something related to astronomy?
Yes, something related to astronomy that can give me a basic idea of it.
Okay.
Like, I know about it, but I wanted to know more about it.
Okay, yeah, that's good. So, for example, there is a book which is called the Bible of Astronomy, which contains a lot of information, and it is a very thick book. It's by Carol and Osti, and you can find it on internet. You can read it you can start any chapter at any point. You don't and understand, or just read for fun. There are questions you can solve in that book. That is for very that book is recommended for students at undergrad level in Cambridge. So I taught students in Cambridge, and I used to refer to that book while teaching them, or not teaching them, but helping them, I would say. Yeah.
Okay, ma'am. Thank you.
Yeah. Also, you can look for internship opportunities, as Nimisha was suggesting. That there are many opportunities like IUCA and one in your institute, Baltimore.
SASP.
Yeah, SASP.
That is Space Astronomy Summer Program.
Mm-hmm. Yeah, okay. Nice to know that. So, okay, so I think that's it. So thank you so much, Nimisha. It was amazing, and we have learned a lot today and got to know more about opportunities and how, and this might have cleared the doubts of many students out there who are interested in astronomy but confused how to follow that path.
Yeah.
So thank you so much, Nimisha.
Thanks to you. Yeah, that was Vijay probably talking. I interrupted. Sorry, Vijay. Well, thanks to you, Vijay. Actually, Shivani told me that was you who suggested that that I should be called. So thanks for thinking of me. That's really nice of you, and it was really nice to talk to all of you guys. And I really appreciate everything you guys are doing. That is a great initiative. I mean, yeah. That's very commendable, Vijay. Yeah.
And
yeah. No, Shivani is actually doing a great job. I mean, for the last 2 weeks or more than that, she has been in constant touch with me. She sent me emails, all the information I needed. She was there to help. So yeah, I really think that Shivani is doing a great job. Yeah.
Thank you so much, Nimisha. And thank you so much, Vijay, for this opportunity.
Yeah, thanks, everyone.
Yeah, thank you so much, Nimisha. And to our audience, I would just inform them that we do have upcoming events in next week on International Women's Day and one on 14th March. So please stay tuned and follow us for more updates on by joining our group, Kalpana Network, on Facebook and LinkedIn. So stay tuned. Thank you.